All right, guys, welcome to Quarantined Algebra 2 for April 2nd. Now that you guys have had 2 days here to work on that, the several problems, like there were 9 problems, I think, on that paper labeled quiz. Again, it wasn't actually a quiz, it was just a paper labeled that. We're going to be moving on to our next section. And that next section starts on this page right here. It should be the 3rd page of your packet. It is adding and subtracting rational expressions that in the first part have a like base, and in the second part have a unlike base. Now, the first thing I want to mention is what the term base means in the context of these problems. A base, in the context of a rational expression, is the denominator. So, really, we could just be saying, sorry, my cat's trying to get in the photo there. Really, we could just be saying having a like denominator or an unlike denominator. Now, what I want to do before we actually start one of these problems is talk about adding fractions. I know it's a very, very simple topic that you probably talked about way back in 4th grade, but sometimes we forget those. So before we jump into one of these, since we are adding 2 fractions, let's talk about it without all the fanciness to it. Let's say we want to do 5 over 7 plus 3 over 7. Well, for us to add 2 fractions or subtract 2 fractions, something must always be true about them. What must always be true? The denominators have to be the same. If you have 2 identical denominators, then what you can do when adding or subtracting is just add or subtract, whatever the sign here says, the numerators. The denominators do not change in addition or subtraction equations. So 5 plus 3, we get 8 over 7. Because again, the denominator does not change when adding or subtracting fractions. When we have a unlike denominator, then we have to work to get that denominator to match. But that'll be something we talk about whenever we get to our second part of this page with unlike bases. But that's not going to be today. So let's go ahead and look at these actual examples and see how they compare. So we see here, we have 13a over 4a squared plus 5a over 4a squared. We have 2 fractions, and both of them have identical denominators. So what we want to go ahead and do is combine these. Go ahead and add these. You may be looking at them and thinking, well, can we simplify some of them? We have some variables in the numerator and denominator that could cancel out. Do we want to just simplify them right away? In this instance, we don't. Because if we were to simplify each of these individually, there's a chance that these denominators would no longer match up. They would become dissimilar. So we want to go ahead and add them while they're the same, and then we can cancel out what there is to do. So let's go ahead and do that. These have identical denominators, so we know the denominator of our combined fraction, or the sum of these, is still going to be 4a squared. And then the numerator is just going to ask us to add 13a and 5a. Since both of these variables, or both of these terms have the same variable with them to the same exponent, we can combine them. 13 plus 5 is 18 and a. And at this point, we can simplify anything in this answer. Now that we've broken it down into just one fraction from the 2, we can simplify this. 14 over 8. If we had to simplify that, it would break down into 9 over 2. And then we have a over a squared. Well, as we've talked about before, 2 minus 1 leaves us a single a remaining, and that a is going to go in the denominator. And this is our fully simplified answer. We were able to break down 18 over 4. We were able to simplify a over a squared, and we get the sum to our original fractions being just 9 over 2a. Let's go ahead and do this to our next problem as well. Number 2 here is actually a subtraction problem, but again, it works the same way with the denominators being identical. So again, I'm going to go ahead, keep my denominator the same. Since they're matching already, they're going to be able to stay the same and through to the answer. And then I'm going to go ahead and do the calculations in the numerator. Now, there's one really important part here. We're subtracting this whole numerator, right? So it's really easy to look at this and say, well, it's minus 7x, but then plus 2, because that 2 has a plus in front of it. But we're subtracting all of that. So what's actually going to happen is it's going to be minus 7x minus 2. That minus sign distributes to both parts of that second fraction. We've dealt with that a couple of times this year, but it's always important to remember that that happens. So we can combine like terms here. We have 9x minus 7x, so we're going to get 2x there. And then we're going to have 12 minus 2, and 12 minus 2 is going to be 10. So we get 2x plus 10 over 16. So this one is just a little bit different than the last one in the sense that it has a binomial in the numerator. But we've been dealing with binomials and all that for the whole last 2 weeks, so that's no problem. Whenever we do this, we want to go ahead and factor out what we can. Factor it out, or box method it if that's a possibility, that kind of thing. So we're going to go ahead and factor out. 2x and 10 have a 2 in common, and then we'd be left with x plus 5 after we divide 2 out of both of those, over 16. At this point, just like we were seeing in our last unit, we have 2 over 16, two whole numbers that can simplify. Well, 2 over 16 is going to simplify into 1 over 8, right? Take 2 out of each. So that would leave us with just x plus 5 in the numerator, because we don't got to really write that 1, over 8 in the denominator. And this gets to be our final answer to the problem. We're going to do one more of these together, and that will be number 3. So let's go ahead and simplify number 3 here. Again, the denominators are the same, so our answer will have that denominator, y squared minus 9. And then we have in the numerator, we're adding, so that's going to make it a little bit easier. We only have 1 y squared here. We have 8y and 2y. That's going to make 10y. And then we have 21. Okay. So now what I want to do is I want to look at this and I want to simplify it in any way possible. Just like with rational expressions, I want to break it down using factoring it out, box method, or difference of squares. If I look at that numerator, I know I'm going to have to box method that. That numerator, if I were to box method it, which if you're having any trouble with the box method, check out a video from about a week ago on the Google Classroom. It's specifically just about box methoding. So if you're like, how are you box methoding this? How do you do that? How are you getting your answer? Check out that video. There's a tutorial just for it. But that's going to end up being y plus 7 and y plus 3. And then our denominator, we have y squared minus 9. Now, we can't factor it out because they don't have anything in common. We can't box method it because there's only 2 terms. So we are going to have to difference of squares because it's subtracting and there's 2 perfect squares. Y squared is a perfect square, 9 is a perfect square. So if you recall, difference of squares, what we do is we take the square root of each. So the square root of y squared is y. The square root of 9 is 3. And then one of these we're going to be adding, one of them we're going to be subtracting, just like so. Now that we have this fully broken down, fully factored out, we can see if we have any of those redundancies, those terms that appear both in the numerator and the denominator that we can cancel out, that we can eliminate. And we do have that. We have a y plus 3 in the top and the bottom. So we're going to cancel out each of those. We will end up with y plus 7 over y minus 3, just like so. That would be our final answer. All right, so what I would like you guys to try out is numbers 5 and 6. I say not number 4 because I don't really like how these go with the opposite difference of squares. I think those problems are just kind of a little bit annoying, truth be told. They're a little bit confusing for confusing's sake, if you will. So try out 5 and 6. What we'll do is in tomorrow's video, we will go over those two problems, and then we will start the unlike bases in Monday's video. That's my current plan. If you have any questions, feel free to send them my way. We'll address them in a future video. All right, see you tomorrow, guys.